Hello, welcome to this webinar. My talk today is on what is solar radiation modification and why is it important. The presentation is supported by material in the fifth assessment report of the IPCC, the Intergovernmental Panel on Climate Change, and the more recent special report on global warming of 1.5 degrees Celsius. The links of these reports and the relevant pages addressing SRM, Solar Radiation Modification, are indicated in this slide. More updated scientific findings on SRM will be included in the sixth assessment report of the IPCC, which is planned to be published in 2022 or 2021. So before I start talking about modification of solar radiation, let's recall that solar radiation relates to radiation emitted by the sun in different wavelengths, providing the necessary heat and light for life on Earth. Basically, 30% of the sunlight that reaches the top of the atmosphere is reflected back to space due to clouds and aerosols, and also light-colored areas in the surface of the Earth, such as deserts, snow, ice. The energy that's not reflected back to space is absorbed by the Earth's surface and atmosphere. And to balance this incoming energy, the Earth must radiate, on average, the same amount back to space. It does this by emitting long-wave radiation continuously. However, greenhouse gases absorb part of the infrared radiation emitted by the Earth's surface, trapping heat within the surface and the lowest part of the atmosphere, creating the well-known greenhouse effect and increasing the average global surface temperature. With more and more anthropogenic greenhouse gas emissions being emitted, the greater the greenhouse effect becomes. So, if the greenhouse gas effect can be reduced, energy can be emitted to space more effectively, and the average surface temperature will be reduced. Also, if less sunlight is absorbed by the Earth by making it more reflective, the average temperature will also be reduced. So we are identifying some means to change the radiation balance of the Earth, including by altering the long-wave radiation from Earth back to space, by changing the concentration of greenhouse gases in the atmosphere, and also by changing the fraction of solar radiation that is reflected back to space. Solar radiation modification relates to a range of measures to modify the radiation, seeking to limit global warming. These measures can involve reducing the amount of incoming solar radiation reaching the surface, but can also allow more long-wave radiation to be emitted back by reducing, for instance, the optical thickness of clouds, which also has a blanketing effect similar to that of greenhouse gases. In their 1.5 special report, the IPCC assessed several greenhouse gas emission pathways consistent with limiting global warming to 1.5 degrees Celsius by the end of the century. And in some of these pathways, called overshoot pathways, the warming exceeds 1.5 degrees Celsius before the end of the century, but returning to this level of warming by 2100. In the report, solar radiation modification was assessed in terms of its potential to help reduce the elevated temperatures and associated impacts. The most researched solar radiation modification method is the stratospheric aerosols injection, which involves injecting a gas in the stratosphere, which then converts to aerosols that reflect more radiation back to space, causing less radiation to be absorbed by the Earth's surface, thus producing a cooling effect like that observed after strong explosive volcanic eruptions. There is high agreement in the scientific literature that SRM could indeed contribute to limit warming to below 1.5 degrees Celsius. Other, less researched methods include ground-based albedo modification, which changes the fraction of solar radiation that is reflected through more reflective surfaces, like whitening rooftops. Another SRM method is marine cloud brightening, that through the direct injection of sea spray particles make clouds become brighter, reflecting a fraction of the incoming sunlight back into space. And finally, cirrus cloud thinning, which aims at reducing the optical thickness and cloud lifetime, and by doing so, allowing more output long-wave radiation to escape from the Earth to space. This slide is a representation of some solar management modification methods, which are shown in the bottom box at the right of the figure. G, for instance, suggests placing reflectors in space in order to reflect solar radiation. In H, aerosols are injected in the stratosphere, as previously mentioned. In I, marine clouds are seeded to make them more reflective. In J, the ocean surface is made more reflective by producing microbubbles in the sea surface. Finally, K and L are examples of ground-based albedo modification method by growing more reflective crops and whitening roofs and other built structures. Finally, why SRM is important? The scientific knowledge so far recognizes that mitigation measures alone are not sufficient to achieve aggressive climate stabilization targets, such as that of 1.5 degrees Celsius. Hence, SRM and other methods, such as carbon dioxide removal, must complement the mitigation efforts. The theory, model studies, and observation suggest that some SRM methods may be able to counteract a portion of global warming effects due to high concentrations of anthropogenic greenhouse gases. But the level of understanding about SRM is low, and it's difficult to assess the feasibility and efficacy of the methods proposed. But the IPCC acknowledges that enough is known to identify some potential benefits, which must be weighted against known side effects, some of which may not yet have been identified. In summary, SRM may help avert potentially catastrophic temperature increases, but may have negative impacts with respect to global and regional climate conditions, which other colleagues in this webinar will address. So thank you very much for your attention and hope that this has been helpful.